does it look like a problem? When was the last time you had 5 numbers to add? When was the last time you had to do that? So off you go. What I really want to explore on this one is method. What strategy you're going to approach to add this. And column method, nah. The brain doesn't, I'll tell you, if you learn the column method, that's not how your brain, our brains are not wired to work like that. So do you have another strategy, a more efficient strategy to add large sets of numbers? Let's see what you go. I'm giving you a few moments as usual. Then I might invite you to use the power to pause. That's how we do it before I go through it. But yeah, off you go. By the way, I need to the music. Are you feeling the music today? Distractions. I'm gonna try and keep it a bit low on the distractions. Well, my attempt at distracting you, but hey, as I said, it's live. Me sitting down here doing nothing. I gotta have something to do, but yeah. What I'm gonna do, you know what? I'm gonna do this on paper using the column method. That will kind of simulate. I've got an envelope here, so I'm gonna do it on the column method and just simulate. You know, like how long is this actually gonna take if I did it 5, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah. So using the column method, I'll finish, and but that's not the way I'm gonna do it. So you got an answer? Got an answer on that one? We're looking at what would they have there? We're looking good on this one. Adding. How about I'm gonna start doing it. If you want to finish off, use the power of the pause. Use the power of the pause. You can pause live shows as well, and we'll catch up later on. That's perfectly fine. Remember, I'm involved in the. I try to get involved in the chat. It's difficult to chat and type. Well, to do the maths and all of that. But as far as possible, I'll have a look at the chat and try and pop in some points there. Okay, right. So what do we have? We have 500. I'm going to add the hundreds first. 500. And let me get a different color. This is the approach I want you to think about this as a strategy. That's 1100 there. Then I have 800 and 700. So that's 1500 there. 1500. And then we have the 900. And that they link quite nicely because as soon as I see the 1100 and the 900, well, that's going to be 2000. So 2000 plus the 1500, 2000 plus 1500 is what I have in terms of hundreds, and that will give me 3500. So that's the first total there. Then I'll go to the tens. So this is my hundreds. Now I should have let me stick with red. So the red, I've added the hundreds. Now I'm going to add the tens. In terms of the tens, 3, 7, 12, 12, where I lost myself, 7, 12, 12, 19, 19, and 7. 19 and 7 will give me 26. So what I'm getting there, have I done that right? 13, 13, and 5 is 18, 18, and 4 is 22, 25. So 25 is what we're going to get there, which will give me 25 tens is 250. Now, one of the things that comes up with this, and why you saw that pause there, let's just explain what was going on there. It's because I started adding the 3 and the 4, 3 and 4, 7 and 5, 12 and 6, 12 and 18 and 7, 25. But for a moment I paused because I was thinking, am I looking for my number bonds? Do you look for your number bonds? Do you take that moment to see if there's any number bonds? So for example, we had 3 tens and 7 tens. That will give me 10 tens. That's 100, 30, and 70. Then there was the 4 tens and the 6 tens. That will give you another 100 there. And then you have the 5 tens left. So that's another strategy, another thing you want to be looking for. But it comes with experience, having that quick scan and seeing if you can find number bonds, which will make the adding even faster. Now note, I'm explaining, I'm doing what I call visible thinking. So I'm explaining everything, but if I was totally focused on actually doing the addition, those are the kind of things that will be happening in my mind as quickly as possible. It is always useful to look for a pattern before you just dive in to do it the long way, shall we say. Okay, so 250 there. And then the last thing I have to do is add the ones. So I would scroll up a little bit. I want to get the ones. I'm going to use green for the ones. And the ones you can get, we have 1 and 2 and 3. That's 6 and 4, 10. And 10 and 5, 15. So 15 is what I would get with the ones. Taking this approach, once we're finished with it, you'll find that actually the addition, there's no carrying over, which is the bit that potentially creates problems with your addition. What do I have? I have 5, I have 6 and 5, 6 and, what am I doing? 5 and 1 is 6, 2 and 5 is 7, and then we bring down to 3,000. So 3,765. 3,765. There are, this is a different, I'm not sure if this is not the way you go about doing your addition, maybe this is a strategy you want to add to your toolkit. How about add the hundreds, add the tens, add the ones, and then put it all together. You'll find it's a lot easier. Once there's a bit of, I suppose I'll use the word unlearning, because by default we know we practice and drill, many of us, the column method so much that sometimes it's difficult to let go and embrace new ideas. But I can assure you this technique, and there's lots of other techniques for addition, they're way more efficient than the column method, because it helps, it's how it fits in more with how you'll do questions mentally. And for a lot of addition, if you're not doing a calculated paper, you want to be employing mental methods. So something for you to think about there. Addition. Right, now, I just saw a spider. Spider's climbing up the wall behind me. Naughty, naughty spider. Okay. Right, let's go on to another one. Okay, let's go on to another one. And this one, woo, a lot more reading. These questions, by the way, these are MOEMs. Maths Olympiad, that's a Maths Olympiad for elementary, that's elementary school and middle school. So elementary, that's primary schools in the US. Middle school runs like upper primary into, yeah, middle school is like upper primary into Key Stage 3 in the UK. I think that's a good, in terms of breaking it down for you. But if anybody in the US watching, do clarify my understanding of your system, but think it's like that. But these are Olympiad questions designed for students, so perfect for us, 8 to 13. That's the age group being targeted here. Right, so you have the chance to read this one. I think I'm going to start using this as a strategy more, where I'll do the question on paper and see, and then I'll do it. Right, so you're off on this one, okay? What I was saying, this is a picture is worth 1,000 words. Draw a diagram, visualize it. Okay. I'm sorted. Are you sorted? Did you get a chance to read the question in enough detail and get an answer for this one? Is it time for us to be talking? If you need additional time, the power of the pause the video, you continue, you finish your work, and then look at my discussion, see how that works out for you. And really remember, it's not just about the answers, it's about comparing methods and just thinking about, it's about developing different strategies, different ways of seeing things. That's really important if you want to become a good problem solver. For a question like this, I would always draw a diagram. I will always draw a diagram. So it's a rectangle. I'm seeing that it's a rectangle. I have the dimensions of the rectangle. It's an 8 by 12 rectangle. We're cutting it in half twice, first vertically, then horizontally. And I want the area of the new smaller rectangle. So I've highlighted the key information. That's the strategy you want to be using, because a lot of word problems are fluff. A lot of information like Dwayne. Doesn't matter who it is. Doesn't matter because it's just started. This whole question could have just started by a rectangle made out of a rectangle. It doesn't. Oh, even a bit. It's made out of paper. And all of those things is just fluff. And you gotta identify what's the key information needed to make a mathematical model. Take a real life problem, create a mathematical model. So we want to visualize this. We want to visualize our rectangle. Whoa, I did not expect the rectangle to look like that. I didn't even know. Oh, that's slick, using the highlighter to make a rectangle. But we just want a solid pen. So that's the rectangle I'm looking at there. Not in the right position. Okay, yeah, that would fit there. And what we want, and then that's the first rectangle. And we're cutting it, the dimensions, it's 8 by 12, so 8 is the width, 12 is the length. That's the way I would look at it. And the first cut is vertical, so I'm cutting down into half, going down in half. Come on, work with me, it's half. Which means I'm going to end up with a rectangle. I'm going to draw the second one. No, I'm going to put it in. I'll be good. And let's put in the second one. If I cut it down in half, that new rectangle, what's the dimensions going to be? It looks more like a square. I'm sorry. It's going to be 8 going down, not drawn to scale, 6 going across, because I cut it in half. I've cut off this piece. So I got an 8 by 6. And now I'm going to cut it in half again, but this time I'm cutting it horizontally. So that means I'm going to do a split this way. And after I do that split, this is what I have now. That's my new rectangle, and my new rectangle is going to be, is game over for the area? Yeah, sorted on this one. Yeah, picture worth 1,000 words. We're going to have 6, but we're going to have 4. The area of a rectangle, area is length times width. So what we have is 6 fours, which is 24 centimeters squared. So 6 fours, 24 centimeters squared. That's what we're looking at for this problem. The picture, drawing that visual so you clearly could see how the folding impacts on the dimensions, that was critical to success in this question, I would say. You could do it, and remember, I'm making you might have seen that picture in your head. I'm just making everything explicit, but making it explicit yourself, just putting it on paper. You know, you're working on your paper, looking at it. Again, diagram, powerful tool for problem solving. Okay, powerful tool. Where we're going, how we're looking for time. This week I'm gonna be a good boy. I'm not crossing 30 this week. You know, last week I got into some big ones, and I love my maths. I can do this well, actually I do this most of the day, you know, play with the kids, but then work, because it's not work. This is not work. This is having fun, you know, problem solving, thinking about problems, thinking about how you can get other people to explain problems. I love it. Right, let's go for a big one. Yeah, we'll go with this one. Yeah, what I said, big one that you're not gonna get this in school. Yeah, come on, you ain't gonna see one of these in school. So see what you come up with for this. And again, so because I'm trying, one of the reasons, what I'm looking for is ways to improve my timing. I could have a quick scan about what's on the screen there, about what everybody else is doing, which is good, you know. When we run clubs in the afternoon, they can be a bit more interactive. The online clubs in the afternoon, yeah. So I don't have the level of interactivity I probably would like here. It could be a bit, but it's not as top as it could be. Right. So we're doing this on paper. How would you do this question? That's what you're looking at here. You're approaching this one. And I'm just thinking, how would this is a nice one, you know. I just want to highlight that. Whoa! I didn't want to delete anything. I'm going to underline all the really important information. What did I do to pen? Let's get this right. We're going to underline. Right, first 40 and how many 3s? And the key thing there is the odd numbers. I'm gonna highlight first 40 odd numbers. Right, odd numbers. That's really important. making some notes on how we're gonna do this. How you doing? You doing okay with this one, or you waiting for me? You want a hint from me? Probably the easiest way to do this, to be honest with you, is to list out all the numbers. Is probably, and that is that the strategy you're going with, a listing strategy. Yeah, that might, the initial thinking, that's probably the easiest way to run with this. But I'm thinking at the moment, all my numbers are, so this is the first piece of work I'll give you on this as well. I want 40 odd numbers. So if I went from 1 to 40, I'm thinking the odd numbers, what are the odd numbers going to be? 1, 3, 5, 7. I'm skipping out numbers, aren't I? So if I go up to 1 to 40, I'm going to have 20 odds. Okay, and then actually I'm going to have to extend going up to 80, and I won't even get up to 80. What I actually mean is all the numbers, I need to go up to 79 to get the other 20 odds. So in other words, 79. If 80, think about it. If you have 80 numbers, half of them are going to be odd, half of them are going to be even. Make some sense? If I have two numbers, the first two numbers, counting numbers 1 and 2, half of them are odd, 1, half of them are even, 2. If I have 10 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5 of them are odd, 5 of them are even. So to get 40 odd numbers, I need to have the first 80 numbers. And I want the odd ones, so I'm going up to 79. And then you need to start thinking what you need to do. If you want to do the whole listing, that's fine. But what I'm checking out here, and what I want you to be thinking about is how many 3s do you have in the 1s? I'll just put it. You want to be thinking about what's happening in the 1s, the 10s, the 20s, the 30s, the 40s, the 50s, the 60s, the 70s. That's the strategy I'm going to give you there. You need to be listening, and hopefully you can see. Well, in the 70s, how many numbers ending in 3 are you going to have in the 70s? You're going to have one of them. In the 60s, you're going to have one of them. I'm not going to say anymore. I'm going to let you pause there. I'm going to finish this on paper. You have a chance to finish it. Let me see if I'll get any answers coming up here. In the live show, and I try to check back later on. So even if you missed it live, please put your ideas in the chat, ask questions, etc. I try to look on the Facebook page if it's on Facebook, or we're doing. Well, I'm running this on Twitter as well. So if you're watching it on Twitter, Periscope, put it in, and I'll try. I can't promise, but even if you're asking a question and you don't get a response, then on the website. We have an inquiry form on Raymonson.org. Just put any pop questions on there about anything we're doing or anything that we offer in terms of the Mats clubs, the robotics clubs, and I'll get back to you. Okay, right. You're working on this, and let me work on this. I've got to be a bit quiet. Got to be a bit quiet on this one. Right, where am I? This is like us working together. Oh, sorry. Zip it. I gotta zip it. I'm almost done. How you doing? I'm working on it on paper. I'm thinking, am I missing anything? Oh. Okay, right. So how you doing? Are you ready? Are you ready to go through this one with me? Are you ready for me to do this one? Okay. Let's see. We're going to get going on it. Yeah, we're gonna get going. It is time. Yeah, we're gonna get going. Okay, right. Yeah, let's go. Let's do it. Okay. The first counting. How many times does 3 appear as a digit? How many times does 3 appear as a digit? Okay, right. So let's build the whole thing. And I gave you a head start. So you had the 60s, you had the 70s, then in the 50s. And you know what? Actually, probably better if I write down the number. Yeah, the numbers. And that means I'm going to need a bit more space. I'm going to need a bit more space because... Well, I think you know. You know what? I'm gonna give you a hint. I'm gonna need a bit more space because of the 30s. The 30s are really important, aren't they? So let's deal with those first, okay? So the 10s we're gonna have 13. Whoa. 10s we're gonna have 13. For the ones we'll have 3. So 3, 13, and then we'll have 23. Yeah. Then in the 30s we're gonna have 31. 33. Remember, it's only odd numbers, so 33, 35, 37, 39. Then we'll get 43. Then as we continue in the 50s, the 60s, and the 70s, we're going to have 53, 63, and then 73. Okay. Now the question... I didn't underline enough of the question. The question is saying how many times does 3 appear as a digit? So how many times do you have the digit 3? How many times do you have the digit 3? And let's start count how many 3. In other words, actually all you're doing is counting how many 3s you have. How many times does 3 appear as a digit? Once. 1, 2, 3. There's a 1 here. 4, 5, 6. Did you do that? Did you do that? Is that a moment there? 5, 6. How many times does 3 appear as a digit? It appears as a digit twice in the number 33. Did you count that? I think that's the big one where people might have made a mistake here. Did you count that? Come on, let me know. I gotta know. I'm gonna check. I'm gonna check. Did you count that? Okay. 7, 8, 9, 10. 11, 12, 13. So the answer is 13. The answer is 13. How many times did the number 3, how many times does 3 appear as a digit? In the first odd counting numbers, it's 13 times. Why 13? Initially, you'll be counting 12. There's 12. If the question was how many numbers have the digit 3, there's 12 numbers with the digit 3. But how many times does the 3 appear as a digit? That's different. That's 13. No, think carefully about what I'm saying there. How many times the number 3? That's that. How many numbers have the 3? That's 12. But how many times we see the digit? It's 13. Digit 13. Did you like this one? I like this one. This is what it's about. You know, thinking, just attention to detail as well. Okay, right. Oh, boy, I feel good. I feel... You know, after you do one of these, the brain, you just feel stimulated and you just feel good. I feel, even if you got it wrong, you still got to feel, it's like, oh, damn, they caught me with the 33, but it's a good feeling. You know, you're like, I won't get caught with that again. Not, you try that again, Mr. D. I'm going to do it. You know, that you should have that moment. A really, really good moment there. I'm sorry. I'm happy. Where can I possibly go from here? Where we're going to go, we got 5. Let's look at coordinates. Where we're gonna go? That makes sense. We can go different positions on the coordinate grid. So have a look at this one. This is back to the UK. Key Stage 2 SATs 2019. If as of talking today, it's last year's SATs paper 3, question 21. So off you go there. I don't think I've ever done one with the coordinate grid system. So see what you come up with this one. I'm gonna go on to paper mode. That would help me if I'm doing it on paper. That would prevent me from being a distraction to you, and you have your chance to think and all of that. Okay, we'll look at this, and we'll wrap up on this one. Let's wrap up on this one. Okay, right. I labeled it wrong in the diagram, maybe. and doing a sketch. And it's really important, I would say, me doing it like this because it means I'm looking at the screen and I have to do my own sketches, etc. You know, which is good. So we're in this together. You know, you don't have the diagram to draw on, but you can do your sketches quickly and get and move on from there. And that's the first thing I would recommend there to build. Are you done? You got something for me? Okay. And just in case you're thinking you're faster than me, hey, hang on. Just to be serious about this. I'm doing this, but I'm not just thinking about actually getting the answer. I'm thinking about what am I going to talk to you about, describe what I want to get in the processes. That's my excuse for taking so long, you know. If you think I'm taking a little bit long, that's my excuse. Right, where was I? Okay. I've done it, and I've done it in such a way to thinking about teach it, so I think we're ready to do it together. And let's look at this together, okay? They said we're told the important information you have here is that C is the center of the rectangle. C is the center. What does that mean? What's the implication of that? It means that the distance to this x coordinate, this line, which is on the x-axis, the name of that line is x is equal to 25. That's the name of that line because we have x and y. So that's the line x equals 25. And we want to get the x value. Okay, and that's the learning point there. Your vertical lines x equals. If you go all the way down straight, it's cutting through where x is equal to 25 on the grid, then the name of the line is x equals 25. So in other words, this line going down through C, that's my x value there, 40. The name of this line is x equals 40. So just giving you an introduction to naming lines. If this is 25 and this is 40, then the gap from 25 to 40 is 15. If C is in the middle, then going on the other end, the gap has to be 15. So in other words, if I started at 25, I need to add on 15 and 15, 30 to get to the other side. It's telling me that the x coordinate for B and D is going to be x equals 55. I've added 30. It has to be the same distance on either side of the midpoint. That's the idea we're working with. And then we need to do the same, it's the same idea we need to follow through when we're looking, when we're going down vertically. If I do a split now, and the name of this line will be y equals, yeah, you guessed it, y equals 30. So it's cutting the axis at 30. Okay, and we want to work out, well, what coordinate is here? What am I going through here? And the way we'll do that is, again, if that was my midpoint, I'm at 22. I'm at 22 here. This is the line. Y equals 22. Y equals 22 there. If that's 22 and I went to 30, that means that the height going up, half of the height of the entire rectangle is 8. The other height has to be 8 as well. That's my center point, 8, 8. So I went up 8 from 22 to 30. Now I need to go down 8. So when I go down 8, what do I get to? I get to 14. 14 and 8 will give me 22. So now, coordinate of B, well, B is on the x coordinate is 55. And the y coordinate going across is 30. For D, what's the x coordinate? Yeah, The x-coordinate for D is the same 55. They're both on the same x-coordinate, share an x-coordinates 55. What's the y-coordinate? Going across, I read off, it is 14. So 55, 14, that is the y-coordinate. And that is the answer to the question. To this one now. So this is my sort of my special for today. You're gonna have, I'm gonna read it with you, and then we're gonna show again. I'm sticking on it. A picture is worth 1,000 words. So Dwayne, me, I realize that I can calculate the height h of a tower without climbing to the top and using a tape measure. I mean, think about it. Eiffel Tower. You wanted to, what, you want to climb up on that thing? You want to measure it going up? Let's be serious. You ain't gonna, not going to work out very, very well, to be honest, you know? And this is how they used to do it back in the day. You know, one of the strategies he notices that when the sun just appears over the top of the tower, the shadow of a 2-meter stick that is 32 meters from the tower is 4 meters long. What is the height of the tower? Now, listen. To pull this off without a diagram, all the best to you, you know? You need the diagram for a model, okay? But, so, let's show. Let me show you my graphic style now. You were laughing at me with the circle. Watch this. Watch this. Boom. Look at that. Tower. I got myself a tower with a sun. Oh yeah. Oh yeah. Never, yeah. Are you impressed? And I drew that for myself in PowerPoint. That ain't no rig. I did my, yeah, I drew that for myself in PowerPoint. Oh yeah. Not the sun, just the tower. And you, well, actually, fair enough. It's a bit wonky. Yeah, not my thing, is it? Right. So we have the sun shining, and then what you actually want is the model of the stick. This is actually the useless bit, to be honest. The tower and the sun, cute, whatever. What you need for your model to answer this question is, boom. And really, see all that waffle that I read? It's not waffle. It's the information used to build a model, but it's very hard to build a model without somebody giving you that diagram. You look at what I've done. I've made all the text smaller because this is a question. What's the height of the tower? And that's the picture. That is the picture you need to be looking at there. That's the picture, and I want to find h. Using that picture, that's what the question reduced to, the sun. And this is a technique that this is how they actually have used through the ages for a long time, how we have used how we have been able to calculate heights. Okay, so how do you do it there? Okay, right, so what do we want? We want, and just give me one moment, I need to bring one thing up that I forgot to bring up. Okay, right, so I'm looking at you doing that bit there, and right, okay, I got that right. Okay, right, just there was a bit, you might have heard it, and this is the joy of doing these things or what have you. I heard a little ding dong and I had to check for what was that about. That was an important message on the computer screen. Forgive me. Let's get back to the work. Ooh. Okay, so let's do this. And you have the power to pause. Remember, you have the power to pause to do it, okay? You have the power to pause. I'm going to type it. Can I type? Yeah, can I type? Should I type? Topic. That's what I want you to be thinking about. Similar shapes. Do you know about similar shapes? What do you know about similar shapes? See what I put in there? Similar shapes. That is what we're talking about here. That's what we're interested in. Similar shapes. And actually, we're not going to use. I'm going to if I mention the word trigonometry. Ever heard trigonometry? That's great, but we're not going to use it. We don't need it. Don't get scared. We're not going to do trig. We're not going to do trigonometry. But I can tell you that the idea we're using is the idea that trigonometry is based on. Now, the thing you need to see here, look at what's happening here, is two triangles. Can you identify two triangles? And those are the two triangles that are similar. And once we deal with those, you'll see how easy this question starts to become, or it becomes, if you can spot the two similar triangles. That is the key to this question, spotting the two similar triangles. And I think when you see the similar triangles, the relationship between them, it sort of becomes intuitive, and you should be able to work it out. These are we have two similar triangles. And I'm going to identify the first one of you. You seeing one? Are you seeing the two triangles? Can you see the two triangles? The first triangle is this small one with the stick. That's your first triangle there. And I'm going to draw it on the outside here. And we're going to put the measurements. We have a 4 and we have a 2. So in other words, the height, and oh, this is where I almost give away the question, I think. The height is half of the base of this triangle. The height of this triangle is half of the base. Similar triangles. What does that mean? I'm going to say that again. The height is half of the base in this small triangle. Can you see a big triangle? If you see that big triangle, and note what I just said, the height is half of the base and the triangles are similar. What's the height of that tower? You getting what I'm saying? Are you seeing the big triangle? Big triangle. Let's deal with this big triangle. Whoa, whoa, whoa. Big triangle. Now this is where a lot of people get caught. What's the base of this big triangle? It's starting here. Note, that's the first point. They're sharing a point, these triangles. It's the base going whoa, 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 whoa. The length of that triangle, the red one, the base, is 4 and 32, and 4 and 32 is 36. Game over for question. And then the triangle extends all the way, and the height of the triangle is the height of the tower. The triangles are similar. That means that the angles are the same. The ratio between the base and the height is the same. That is the principle of what all the ratio between the lengths of the triangles when the angles are the same. That's we're going in. That's the basis of trigonometry, which we don't need to learn or use here. But what's the height of the triangle? These are triangles where the angles are the same. And how do I know? How do I know the angles are the same? Well, they're sharing this angle. Aren't they sharing this angle? Whoa, damn. Oh man. Right, you see? They're sharing. The small triangle has this angle, and the big triangle has that angle. Then what angle is that? It's a right angle, 90 degrees. Yeah, this one has a right angle, 90 degrees. So the two angles in the corner are the same. The angle here is the same. Angles in a triangle add up to 180 degrees. So if these two angles are the same, all angles in triangles are 180 degrees. What it means is that the third angle has to be the same. So they have all the angles, all the corresponding angles. I'm getting into the formalities here, but the angles you can match up are the same. And if that happens, then the triangles are similar. The ratios between their base, the proportional multipliers, the scale factors, whatever you want to call it, between their lengths are the same. The height was half of the base. The height has to be half of the base. The height of the triangle, the height of the tower, 18 meters. 18 meters. Big idea there, big idea there. An idea that will take you through, as I said, this is the basis of trigonometry, a huge, huge topic that you're going to be doing right through A level, and we're starting to build the idea here. It enables you to find missing angles, the trigonometry stuff. We don't need angles, we needed that 18, that's it, sorted. How you feeling about that? Looking good, looking good? Right. Let us go to another one. Let us enter the Which one I wanted to do? Yeah, I want to do this one first. This is not what I had in order, but I really want to do this one because this has just like been sitting on my notebook list for, I don't know, for about 2 weeks now, and I just haven't got it up. Let's do this one. We just talked about ratio. Let's see if we can ace this ratio question. This is recent GCSE exam paper question, different to what you would have had in the back in the day. So this is original stuff. A bit of reading, so I'll give you a moment to read it. You be quiet there and read it. A chance for me to just check up on a couple things, see what's going on here. Okay, so you have your chance to read it there. Okay, right, you're ready? You ready? I've given you a moment to think about the question. I do have to get started doing it. We're gonna start building that now. Okay, let us start this whole thing. Right, okay, so let's see what we have here. We have, and if you need more time, remember you got to use the power of the pause. I'm restricted by the amount of time I can give you because of well, I got to stop in a few minutes, you know. So this probably might be the last one that I'm gonna look at today. Yeah, once we get at least 3 questions looked at, that's good, I think. Might be able to do a 4. No, we're gonna stop on this one. We're gonna stop with this one. I've been taking it easy. Okay, right. So the ratios 7 to 4, 7 to 4, and you want to label this thing. You have the houses. It's houses. Yeah, we found houses. Then we have information about flats. And houses to flats, the ratio of houses to flats, we're told is 7 to 4. And then the second line is telling us about flats. Sorry, let me manage my colors. Got to keep the colors. The flats to bungalows. So flats to, look at what I'm doing here. Look carefully what I'm doing. I'm not creating a new ratio. I'm going to say flats to bungalows, and I'm just going to write it down here. The ratio of flats to bungalows is 8 to 5. I think it's game over by what I did there. So that's the picture I'm giving you there. Do you know where, if you didn't know before, do you know where to go with the question now? Do you know where to go with this question now if you didn't know it before? Yeah. Yeah. So let's see what we're gonna do there. So the bit we want now. Yeah. Okay. Right. So let's get going. Because remember, we want to know what we're trying to find is how many houses, but we know how many bungalows. And the only way you can find out how many houses using this information about bungalows is if you know the ratio of houses to bungalows. So we want to make that link houses to bungalows. The connector, the way I call it is the connector is the flats. Because the houses to flats was 7 to 4. Let's scale up. Let's think about a proportional reasoning. What do I do to 4 to get to 8? Because we can work with equivalent ratios. If I multiply the 4 by 2, I get 8. That means I multiply the 7 by 2, I get 14. The 7 to 4 ratio, which means for every 7 houses you have 4 flats, it's the same thing as saying that for every 14 houses you have 8 flats. It's the same ratio. It means I'm going up in 7. 7 houses, 4 flats. Another 7 houses, another 4 flats. That's 14 houses, 8 flats. The ratios are equivalent. And now because the value of the number of parts for flats, 8 flats, is the same for the house to flat ratio, the first one, and the flat to bungalow ratio, the second one, we now have a ratio for houses, flats, and bungalows. For every 8 flats, you build 14 houses and you build 5 bungalows. That's the ratio for houses to flats to bungalows. 14 houses, you must build 8 flats, you must build 5 bungalows. We've made what was 2 ratios is now 1 ratio. That's what we've done there. We've combined the ratios by using an equivalent ratio for the first one. 7 to 4 is 8 to 14 to 8. To finish the job now, 50 bungalows. So let me just put it down here. We now have houses to bungalows to flats is 14 to 8 to 5. And we use exactly the same technique. Now we're saying there's 50 bungalows. So if there was 50 bungalows, how many houses? How many houses do I need? You ask yourself, it's proportional reasoning. You ask yourself now, what do I multiply 5 by to get 50? What would I multiply 5 by to get 50? And I would multiply by 10. I'll multiply by 10, and that means the houses you need to multiply by the same number. 14 multiplied by 10, and 14 multiplied by 10, 140. So if you're making 50 bungalows if there's 50 bungalows in that village, there has to be 140 houses. That is your answer there, and that is, you've seen that technique of how you can combine ratios. Ratios comparing 2 items or two things, houses and flats. We can actually combine them and see the link between 3 objects, in this case houses, flats, and bungalows. Okay, and we'll stop there. I think powerful idea. Didn't get the power and powerful there, but I got it right in the end. And I hope you enjoyed that. I hope you've enjoyed. If you haven't been looking, we're now at 35 problem solving videos. In some of the sessions we go through about 7 questions, some 5. Today we went 3. You probably have, I need to double check it, but what I'm sure about, there's over 100 problems solved on Raymondson. For you have 35 problem solving sessions you can go through if you haven't experienced them as yet. And even if you've done them, you want to go back over and see the things that you couldn't do. Could you do it now without me going through it? Are you able to do it now? So you got 35. We want to get up to 50. That's the aim. The intention was to go down to keep doing these free sessions until the end of May. I've put in my mind now. I'm just gonna go. I'm gonna work towards 50, and then after problem set 50, we would change how often we do these. But please take advantage of them. And if you're looking for a more structured approach, more focus for your age level, more focused challenge and additional support, then you probably want to look at some of the classes we run, the private classes that we run, small group classes. Okay, so if you want to find out more about those, do get in touch. And yeah, well, I'll leave it at that. Enjoy the weekend. Hopefully the weather is going to be good. If this is, actually I say weekend because I'm recording it's Friday. If you're watching it at a different time, enjoy your next time in life. Did I get that right? Wow, great. All right, take care of yourselves. Mr. D is out. Bye bye for now. Take care. Bye.